Welcome to Astronomy Daily, your daily dive into the cosmos and the latest headlines from across the universe. I'm Avery.
And I'm Anna. We're so glad you could join us today for another fascinating look at what's happening out there. We've got a great show for you, covering some truly groundbreaking discovery.
Absolutely. Today we're going to explore some amazing new research that might have finally solved the mystery of how Earth's protective magnetic field formed billions of years ago. It's a story that reshapes our understanding of early Earth.
We'll also be bidding a fond farewell to a remarkable individual, NASA astronaut Barry Butch Wilmore, who is retiring after a quarter century of dedicated service. His career is truly inspiring.
Plus, we'll dive into some big news from NASA as they shake up their plans for commercial space stations, looking ahead to a post-ISS era. It's a bold new strategy with some significant implications for the future of human presence in low Earth orbit.
And finally, we'll head out to Jupiter's icy moon Europa, where scientists may have just cracked a long-standing mystery about the bizarre distribution of hydrogen peroxide on its surface. Stick around for all that and more right here on Astronomy Daily.
All right, Anna, let's kick things off with a story that truly reshapes our understanding of our own planet, specifically its incredibly important magnetic field. It's a shield that we often take for granted, protecting us from harmful cosmic radiation.
It's fascinating, isn't it? Without it, Earth could end up like Mars, losing its atmosphere and becoming a very hostile place for life. Our planet has maintained this critical defense system for billions of years. But the big question has always been, how did it form, especially when Earth was much younger?
Exactly, and that's where new research from scientists at ETH Zurich and the Southern University of Science and Technology in China come in. They've provided answers that fundamentally reshaped our understanding of early Earth.
So the long understood theory for Earth's magnetic field is what's called the dynamo effect. It basically describes how the liquid iron and nickel core deep inside our planet slowly cools over time. This cooling creates circular currents of flowing metal called convection currents. As Earth rotates, these currents twist into screw-like patterns, generating electric currents that in turn produce our magnetic field.
That's the basic mechanism, but there was always this significant gap in the theory. About 1 billion years ago, Earth's inner core began to crystallize and solidify. Before that, the entire core was completely liquid. The big question was whether a completely liquid core could have generated the magnetic field necessary to protect early life. It seemed like a critical missing piece of the puzzle.
And this new research seems to have filled that gap. The team developed sophisticated computer models to simulate whether a completely liquid core could generate a stable magnetic field. What's really impressive is they managed to minimize the influence of the Earth's core viscosity to negligible levels, which previous research hadn't achieved.
And the results were conclusive. Their simulations demonstrated that Earth's magnetic field could indeed have been generated billions of years ago in much the same way it operates today. Lead author Yufeng Lin from the Southern University of Science and Technology in China even stated, "Until now, no one has ever managed to perform such calculations under these correct physical conditions. This is huge. It has far-reaching implications for our understanding of how life developed on Earth. Billions of years ago, life apparently benefited from this magnetic shield, which blocked harmful radiation from space, making its development possible in the first place. Without this protection, the intense radiation would have made Earth's surface far too hostile for the delicate chemical processes that eventually led to living organisms. It really gave life a head start, creating a safer environment where complex molecules could form and evolve without constant disruption from high-energy particles. And it's not just about ancient history, is it? Understanding Earth's magnetic field is crucial for our modern world.
Absolutely. Our GPS systems, power grids, and communication networks all depend on this invisible shield. And we know the field has flipped its polarity thousands of times throughout Earth's history. And scientists have recently observed rapid shifts in magnetic north's position. So, gaining a better understanding of how the magnetic field works can help researchers make more accurate predictions about future changes and potential flips that might affect our technology dependent society.
It just goes to show how interconnected everything is, from the deep core of our planet to the technology in our pockets, and all the way back to the very origins of life. A truly fundamental piece of research.
Speaking of incredible individuals and their contributions, we have some news from the world of human spaceflight that marks the end of an era for a dedicated astronaut. Barry Butch Wilmore is officially leaving NASA after a quarter century of service.
25 years is a remarkable career. Wilmore joined the astronaut corps in 2000 and has truly left his mark. He's flown on 4 different spacecraft and spent a total of 464 days off Earth. That's an incredible amount of time in space.
It really is. And during his time, he also conducted 5 spacewalks, racking up an impressive 32 hours outside a spacecraft. Steve Corner, the acting director of NASA's Johnson Space Center, praised him, saying, "Butch's commitment to NASA's mission and dedication to human space exploration is truly exemplary."
He certainly had a distinguished career before NASA, too, serving as a captain and test pilot in the U.S. Navy with both peacetime and wartime operational experience. His spaceflight career began with the STS-129 mission to the International Space Station aboard the Space Shuttle Atlantis in November 2009.
Right, and he also had a long-duration stay on the ISS from September 2014 to March 2015, traveling there and back on a Russian Soyuz spacecraft. But perhaps his most talked-about recent mission was in June of 2024, when he returned to the orbiting lab on the first-ever crewed flight of Boeing's Starliner astronaut taxi, alongside Suni Williams.
That mission was quite the saga, wasn't it? It was originally supposed to last about 10 days, but Starliner experienced thruster issues on the way up. This led NASA and Boeing to extend the capsule's stay on the ISS to study the problem.
And ultimately, NASA decided to bring Starliner home uncrewed. So Wilmore and Williams continued living aboard the ISS for an extended period, eventually returning to Earth on a SpaceX Crew Dragon capsule in March of this year as part of the Crew 9 mission. It was an unexpected end to a flight, for sure, but they handled it with professionalism.
Absolutely. While the NASA statement didn't specify what Wilmore plans to do next, it wouldn't be surprising if he remained connected to spaceflight in some capacity. He shared a powerful reflection, saying, "From my earliest days, I have been captivated by the marvels of creation, looking upward with an insatiable curiosity. This curiosity propelled me into the skies and eventually to space, where the magnificence of the cosmos mirrored the glory of its creator in ways words scarcely convey."
What a beautiful sentiment. It highlights the profound impact space exploration has on those who experience it firsthand. His retirement follows closely on the heels of fellow astronaut Kate Rubins, who also left NASA recently. We wish Butch Wilmore all the best in his next chapter.
Well, from one significant space development to another, we need to talk about the International Space Station because its deorbiting date is fast approaching, estimated to be about 5 years from now. And NASA is making some pretty bold moves to prepare for what comes next.
That's right, Avery. The ISS is the largest object humans have ever built in space, and it's set to be pushed out of orbit and into the Pacific Ocean. This raises a critical question. What happens after that? China's Tiangong space station will still be operational, but NASA faces a serious risk of losing its continuous presence in low Earth orbit.
NASA recognized this challenge years ago, awarding around $500 million to 4 companies to start developing commercial space stations to fill that void. However, there have been concerns about whether any of these replacements will actually be ready by the time the ISS is deorbited.
And that's exactly what NASA's acting administrator Sean Duffy addressed recently. He signed a new directive on commercial space stations, stating that to meet the goals within the proposed budget, a modification to the current approach for low Earth orbit platforms is required. In short, the strategy must be altered.
This is a pretty big shakeup. NASA's previous plan involved a request for proposals early next year, which would have selected one or two companies for assembly and certification. But according to Duffy's directive, there's a significant budget shortfall, up to $4 billion less than what was anticipated for this program. The president's budget request only included $273.3 million for fiscal year 2026 and $2.1 billion over the next 5 years.
So, because of these shortcomings, the new directive introduces some substantial changes to the commercial low Earth orbit destinations program. Instead of moving to a firm, fixed-price contract, NASA will extend the current program of Space Act agreements with multiple participants.
That means a full and open competition for interested companies to receive these agreements, with NASA aiming to award a minimum of 2 and preferably 3 providers within 6 months of the formal announcement. This allows companies more leeway in design compared to stricter federal acquisition regulations.
Another key change is that formal design, acceptance, and certification will shift from this Space Act agreement phase to a follow-on certification phase. Companies won't get certified until after they fly. Plus, at least 25% of milestone funding will be withheld until after a successful crewed demonstration of a space station in orbit.
And perhaps most notably, they've lowered the minimum capability NASA is seeking. Originally, they wanted full operational capability. Now the minimum required is 4 crew for 1-month increments. This is a significant reduction, but it aims to give companies a better chance to develop operational space stations by 2030.
Phil McAllister, who previously directed NASA's Commercial Space Division, commented on this saying, "How was NASA's previous strategy for commercial stations going to work when they lost close to a third of their budget? They had no chance. This gives them a chance." It makes a lot of sense given the budget realities.
This directive also seems to favor certain companies over others. For instance, VAST's Haven 1 module, designed for 4 astronauts for 2 weeks, fits well with the new minimum requirements. They've also been developing their station without government money, betting on a minimum viable product approach.
Whereas the other initial contractors like Blue Origin, Axiom Space, and Voyager Space had been planning larger, more permanent stations. Now they'll likely need to pivot their configurations to meet these new, more immediate goals. One industry official put it quite bluntly, only Haven 1 can succeed in this environment.
It's a pragmatic shift, prioritizing achieving some form of continuous human presence in low Earth orbit, even if it's initially on smaller interim stations, over waiting for larger, more expensive facilities that might not materialize given the budget constraints. It's a testament to how quickly things can change in space exploration funding.
From Earth's magnetic shield and ISS shakeups, let's turn our attention to one of the most intriguing moons in our solar system, Jupiter's Europa. Scientists at the Southwest Research Institute may have just solved a long-standing mystery about its surface chemistry, which has huge implications for its potential habitability.
That's right, Anna. Europa's surface has a puzzling presence of frozen hydrogen peroxide, H2O2. What was really surprising was that James Webb Telescope observations revealed unexpectedly high concentrations of hydrogen peroxide in Europa's warmer equatorial regions, particularly an area known as Terra Regio. This completely contradicted earlier lab studies, which predicted it would be more abundant in colder polar zones.
So, Bereket Mamo, a graduate student at the University of Texas at San Antonio and a contractor with SWRI, proposed a NASA-funded study to investigate this. They designed lab experiments to replicate Europa's environment, observing that the areas with increased hydrogen peroxide also had higher concentrations of carbon dioxide, or CO2. Scientists suspect this CO2 might be escaping from a subsurface liquid ocean through fractures in the ice.
And here's the breakthrough. Mamo and his team simulated Europa's surface inside a vacuum chamber by depositing water ice mixed with carbon dioxide. They then irradiated this ice mixture with energetic electrons. Their experiments showed that even small concentrations of carbon dioxide mixed with water ice can greatly increase the formation of hydrogen peroxide under temperature conditions similar to Europa's surface temperatures. This finding helps clarify those unexpected JWST observations.
The implications for Europa's habitability are profound. Dr. Ujwal Raut, a program manager at SWRI and MAMO's advisor, explained that the presence of hydrogen peroxide alongside carbon dioxide, sodium chloride, and other compounds indicates a chemical cycle. Materials from Europa's subsurface ocean rise to the surface, become irradiated, and form oxidants like hydrogen peroxide.
Over geological timescales, these oxidants could then return to the ocean and react with seafloor reductants, releasing chemical energy that might help sustain life. As Richard Cartwright from Johns Hopkins Applied Physics Laboratory put it, synthesis of oxidants like hydrogen peroxide on Europa's surface is important from an astrobiological point of view.
Indeed. This research provides crucial clues for understanding JWST's Europa observations and serves as a prelude to upcoming close-range investigations by NASA's Europa Clipper, which is already en route, and ESA's JUICE spacecraft. Dr. Ben Teles, another co-author, emphasized that when you combine a source of carbon from the interior, like Europa's ocean, with energy from the magnetosphere, it produces new species on the surface that store chemical energy, a necessary ingredient for dark, habitable ocean worlds where the sun doesn't shine.
It's a fantastic example of how lab experiments on Earth can unlock mysteries on distant worlds, further bolstering Europa's status as one of the prime candidates for extraterrestrial life in our solar system. And it's not just Europa. These findings could also explain hydrogen peroxide on other icy bodies like Jupiter's moon Ganymede and Pluto's moon Charon, where it's also been detected with CO2. And that brings us to the end of another fascinating episode of Astronomy Daily. Today, we've journeyed from solving the ancient mystery of Earth's magnetic shield and its vital role in fostering life, to bidding farewell to NASA veteran astronaut Butch Wilmore after his remarkable 25-year career.
We also delved into NASA's significant strategy shift for future commercial space stations, aiming to secure a continued human presence in low Earth orbit as the ISS era draws to a close. And finally, we uncovered how lab experiments might have solved the puzzling hydrogen peroxide distribution on Jupiter's moon Europa, shedding more light on its potential for life.
Thank you for joining us on Astronomy Daily. We hope you enjoyed our dive into the cosmos.
We'll be back tomorrow with more exciting updates from across the universe. Until then, keep looking up.